Encoder, I just told basic definition, huh? Okay, keep a heading encoder only. Encoder. So encoder is a combinational circuit which will have 2 power
N
n inputs, 2 power n inputs,
N outputs.
n outputs will be there. Clear? 2 power n inputs and outputs will be there. If suppose n equal to 1, so then 2 inputs, 1 output will be there. If n equal to 2, so then it is have 4 inputs, 2 outputs will be there. Okay, so this is 4:2 encoder. So if n equal to 3, so then
8 inputs, 3 outputs.
8 inputs,
3 outputs.
3 outputs will be there. 8 inputs, 3 outputs will be there. Okay, so this is a encoder. Now, so what is the equation? This is y0, right? This is y1. We'll go with this equation y0 and y1 and I0, I1, I2, I3. So if you go with the truth table of this one, how it will be? I3, I2, I1, I0, Y0, Y1. So now, so this one is 0, 0, 0. This one 0, 0, 0, 0. This one is 0, 0. Getting? So next 0, 0, 0. 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1. So these are the cases. Okay, this is the cases. This is the cases. Sorry, this here we will get one right. Why? This is the cases. So now if you write the equation y, so y0 equal to, so when it is high, when I2 is high and I3 is high, I2 plus I3, y1 equal to when it will high, when I1 high plus I3 is high. So you need to be use 2 OR gates, that's it. Yes or no? So y3 when it will high, so y3, y0, sorry, y0, I2 plus I3. These two cases only, right? It is high. So this one is this case and this case it is high. Clear? Sorry? Y0? Two table you didn't understand, huh? I3, I2, I1, I0, Y0, sorry, Y1, Y0. So here also Y1, Y1, Y0. So now 0, 0, 0, 1, 0, 0 case this is 0, 0, 1, 0, 0, 1 case 0, 1, 0, 0, 1, 0 case 1, 0, 0, 0, 1, 1 case. Getting 1, 1 case. So now, so if you are observing, okay, when this y1 is high, y1 equal to y1 equal to this I2 is high, I3 is high, then only it is high, right? I2 plus I3. Y0 equal to, so it is
I1
high at
plus
I1
I3.
plus I3, I3. These are the conditions. So now if you go with this, okay, what you need to do? You need to go with, so OR gate implementation, okay, if you go with OR gate, so I2, I3, so one more OR gate will be there. This is Y1, so one more OR gate will be there. So this is I1, so this is I3. This is the inputs and outputs. I0 will not be there. We want to represent I0. Clear? This is the thing. Go with this. Clear, right? Any questions, any doubts? See, here this one is Y1, this one is Y0. Clear, right? Any questions, any doubts here? This is a encoder. Sorry? This is the one case, 001. Four inputs are there. I1 is high, other all inputs are low. Getting? So I0 is high. Here I1 is high. Here I2 is high. Here I3 is high. That's it. Other all inputs are low. Getting? See, when this input is high, what is the output will reflect? When this input is high, what is the output will reflect? When this input is high, what is the output will reflect? Like that they coded. Four inputs are there. They are making those into two outputs. Getting? This is the thing. If you go with priority encoder, then the things will change. If this one is 1, remaining things are don't care, they will take. So if this one is 1, these two things are don't care, they will take. This one is don't care, they will take. So then the priority will be changed, then that is priority encoder. That is a different topic. Getting? So here, so with this one is high, so I need to be what is the output I will get. Clear? Simply it is coding. So all the inputs are 0, so I will get 0 0. All the inputs are say I1 is 1, so then I will get 0 1. I1 is 2, I2 is 2, I2 is 1, then I will get 1 0, like that it is. Next, see 8:1 also same. 8:1 also, 8:3 also same, sorry. 8:3. So how many inputs are there? 8 inputs are there, 3 outputs are there. Octa to binary they will say. Octa to binary encoder they will say. So how many inputs will be there? 8
8.
inputs will be there. So I0 to
I7.
I7 and 3 outputs will be there. So this is Y0, Y1, Y2. So if you go with the truth table of this, okay, I7, I6, I5, I4, I3, I2, I1, I0. Getting? So now output is Y2, Y1, Y0. These all are 0, 0, 0, 0 case. 0, 0, 0. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is the outputs. This is the thing. So now if when y will be high, when y2 will be high, these all the four cases it is high, right? Yes or no?
Yes, sir.
So y2 equal to what is the equations I will say? Y2 equal to I4, I5, I6, I7. I4 plus I5
I4,
plus I6
I6.
plus I7. So then y1 equal to so in these two cases it is high I2, I3 and I6, I7. I2 plus I3 plus I6 plus I7. Then y0 equal to so I1 plus I3 plus so then it is I5 plus I7. So this is the circuits. You can implement these circuits, right, by using OR gate. So this is the 8:3 encoders. Clear? Any questions, any doubts? If you have a doubt, okay, go with this. Okay. So now you can give here for suppose consider I2 equal to so I2, I3, I1 is there, right? So I2, I3, I1. So I3, I2, I1 is there. For suppose 0, 0, 1 I am giving. 0, 0, 1 I am giving. So which one is 0? I3 is 0. This one is 0. This one is 0. So I2 also 0. I1 is 1 I am giving. So then what I will get? Output is 1. So this is y0, right? This is y0. This is y1. This is 0. So what is this? 0, 1, right? 0, 1 means what? I1. Yes or no? 0, 1 means I1. Yes or no? This say 0, 1. See, 0, 1 means I1. I1 is high. So you can check. Clear? So this is a encoder. Note down the truth table. So why here net is not coming? Clear, right? Circuit able to draw, right? So next go with decoder. So now decoder means what? Decoder means whatever encoded that we need to be decode. Okay, that we need to be decode. So now decoder is a combinational circuit which will have n inputs, 2 power n outputs, which will have n inputs, 2 power n outputs. If n equal to 1, so input will be 1, output will be 2. If n equal to 2, input will be 2, output will be
4.
4. N equal to 3, input
Input
will be
equal 3.
3, output will be
8.
8. 8 outputs will be there. So now this one, for suppose consider this one is A, B, this one is Y0, Y1, Y2, Y3. Okay, so if you go with the two tables, A, B 0, 0, 0, 1, 1, 0, 1, 1. So Y3, Y2, Y1, Y0. Getting 0, 0 case 0, 0, 0.
1.
Here it is not able to write. Okay. Say Y2, Y1, Y0. 0, 0, 0, 0.
0, 0.
What is the output I will get? 0, 1, 1, 0, 1, 1. What is the output I will get? 0, 0.
0, 1. For 0, 0, 0, 0, 0, 1.
These are 0, 1.
0, 0, 1, 0. 0, 1, 1.
0.
1, 0, 0. 1, 0, 0, 0.
So now if you are writing this, okay, equations. So y0 equal to y0 if you are writing, what is the equation I will get?
Okay.
Any other things are high, right? Y0 equal to A bar, B bar. Y1 equal to A bar, B. Y2 equal to A, B bar. Y3 equal to A, B. That's it. Clear? The representation of circuit will be difficult.
No.
Clear, right? Any questions, any doubts here? So you can represent that circuit, right? So how we will represent that circuit? So A bar B, so A bar B, A B bar and AB. Clear? So just I will show you how to represent that one. A bar B, B bar. So now A bar B bar. This is Y0. A bar B. This is Y1. A B bar. This is Y2. A B. This is
Y3.
Y3. This is the circuit. Clear? Any questions? Any doubts? Simply there the OR gates will come here, AND gates will comes. Why net is not coming here? To send that file. Clear, right? This is the encoder and decoder. Okay, so if encoder have 8 inputs, okay, 3 outputs, these 3 outputs will pass as a wires. So then it will be decode. Then it will go to the operation. Right, getting? So then number of bytes will be reduction will be happens easily. So this is the thing. Okay, encoder and decoder. Clear? Any questions, any doubts here? No, right? So then we'll start sequential circuit. Keep a heading sequential circuit. Sequential circuits. Sequential circuits. Sequential circuit is nothing but, okay, it will have a combinational combo plus memory. Combo plus memory. Simply the definition is someone asks, okay. So the output of a sequential circuit depends on present input as well as past output. Past output is there. How that past output will be stored? Past output should be stored, right? So that
Memory.
for that we will use memory element. Best example if I want to say is, okay, so if you have AC, you have a remote, you set temperature 18. Okay, you set temperature is 18 temperature you set. So now you have up arrow, down, right? If you are press up arrow, temperature will increase. From 18 it will increase. If you press down arrow, from 18 it will decrease. Yes or no? So means what? 18 is previous output which is stored in the memory. So now if I will press forward, then it will become 19, 20, 21. If I will make backward, then it will be reduced. Getting? So that is the sequential circuit. Simply if I want to say. TV remote also same. You are okay. So you press 10. So 10 channel is there. Forward it will go to the 11. Backward it will go to the 9. Yes or no? Means it is storing that element and it is operating on that previous output as well as present input. Both it is taking. It is not ignoring anything. Yes or no? So this is the thing. If suppose you directly enter 20, if you want to go to the 20 channel directly you enter 20, it will consider the memory? No. Getting? Depends on the what input you are giving, the sequential circuit operation will be different. But when we are defining someone, okay, we will say sequential circuit means, so it will be the output of a sequential circuit depends on present input as well as past output. So this is a sequential circuit. Sequential circuit having a combo logic as well as memory element. If someone asks, okay, what is the difference between combinational circuit and sequential circuit? Okay, so one is memory element difference. Second thing is feedback we will give. This is the second thing. Third thing is, okay, sequential circuits are depends on clock. Okay, depends on clock control. Okay, different types of edge triggers, level triggers will be there in the sequential circuit that we will not see in the combinational circuits. Okay, combinational circuits are very fast. Sequential circuits are slow because it need to be processed the previous memory as well as present input. It will be slow compared to the combinational circuit. Clear? Any questions, any doubts here? So now the sequential circuits are two types. The sequential circuits are two types. Any guess what are those?
Synchronous, asynchronous.
Asynchronous, synchronous. Asynchronous sequential circuit will not control by the clock signal. The output of a sequential circuit will not control by the clock. Okay. Simply, if you want to say, okay, So the output of sequential circuit, okay, will not be depends on the clock. It depends on the clock. That is a asynchronous. Synchronous means the sequential circuit output will be depends on the clock signal. If clock signal is present, so then only it will be turned on and output will be generated. Depends on one different types of triggerings will be there. So based on the triggering, it will be turned on. Synchronous sequential circuit means here not depends on clock. On clock, it will be depends on clock. That may level, that may edge, that things we will discuss. Clear? So there are two types of sequential circuits are there. Synchronous, asynchronous, asynchronous. Synchronous means it will depends on the clock period, it will turn on and then output will generate. So asynchronous means, okay, it will not depends on the clock period. Okay, the output will not be sync with the clock period. Means clock period is present, clock is present or not present, output will be generated directly. Those kind of things are asynchronous. Clear? Clear? Any questions, any doubts here? Sequential circuits, this differences, these all things. So now next we'll go with different types of what is the clock, what are the different clock, because see we are saying here the difference is asynchronous, synchronous, clock only we are saying difference, right? What is the clock? Clock first. What is the clock? Clock is a signal. Clock is a signal which repeats after certain interval of time. Clock is a signal which is repeat after certain interval of time. That is a clock. Now if you observe this clock will repeats after certain interval of time. Clear? Clock period clock have on time, off time, on time, off time. On time plus off time, okay, will call period equal to on time plus off time. On time plus off time together will call the period. So on time can be greater than off time. Off time can be greater than on time. Means here I am saying on time and off time both are equal. Okay, here I drawn like that. So if see on time can be more, off time can be less. Like this also will be there. Okay, like this also will be there. Or on time will be less, off time will be more. Like this also will be there. Clear? Like this also will be there. So now the next thing is duty cycle. Duty cycle. What is the duty cycle means? On time T on by T on plus T off. T on by T on plus T off. Okay. So this is a duty cycle. This is equal to duty cycle. Duty cycle. Clear? T on plus T off both equal to time period T, right? Time period. Yes or no? Time period TP if you are consider. So T on by time period equal to duty cycle. Duty cycle. Clear? This is a duty cycle. Clear, right? So T on plus T off equal to duty cycle. T on by T on plus T off is TP. TP equal to duty cycle. Clear? Frequency means what? Frequency means frequency equal to 1 by TP. This is the frequency. Frequency equal to 1 by TP, time period. Clear? Any questions, any doubts here?
No, sir.
So next, in the clock period, if you observe, this is one clock period. This clock period have, okay, two types of things will be there in this clock period. One is levels. This is this or this. This will call the levels. Okay, these all, these all called levels. I think it is not visible. Let me write with levels. Okay, so the same way, the clock period will have
Edges.
edges. This all will call the edges. These all will call the edges. This one. Edges. These all will call the edges. So now in the clock period only, if I will take only maximum value, level, so that level will be called the positive level. This is negative level. Positive levels are two types. Positive level is there, negative level is there. The same way edges also two types. Edges also two types. The edges also two types. So the edges also two types. So what are those?
Up edge, down edge.
Positive edge, negative edge. Positive edge, negative edge. So how I am saying this is positive edge? The clock signal which is goes from 0 to 1, that is a positive edge. The clock signal which is go from 1 to 0, that is a negative edge. So the same way the clock period which is reaches to 1, so then that is a positive level. Okay, that is a positive level. If the clock period which is reaches to 0, that is a negative level. That is a negative level. Clear? Clear? Any questions, any doubts? Here clock related parameters. So what is the duty cycle? What is the frequency? What is T on time? What is the T off time? Is T on time equal to T off time? They will ask this all the kind of questions. If T on equal to T off time, so then what is my duty cycle? They will ask 50%. Because T on equal to T off time, what happens? You can substitute here also T on time. Okay, T on plus T on 2
1.
T on. T on T on will be cancelled 1 by 2. So 50%, 1 by 2 into 100. 50% duty cycle we will get. Getting? So like that questions they can ask. Okay. So on the duty cycle, okay, so they will give this clock period and they will give the time periods and they will say calculate the duty cycle, calculate the frequency. So this kind of question they will ask. Clear? This is the thing. So these are the parameters. Okay. Clock will have 4 things. Okay. Normally 2 things they will say: levels, edges. Okay. So levels will be there. Levels and edges will be there. In the levels, 2 types: positive, negative. So in the edges, 2 types: positive, negative. So if a sequential circuit which will be turned on only at positive levels, okay, positive level, that will call the positive level triggered. Okay, if a sequential circuit which will turn on only at negative level of a clock signal, so that sequential circuit will call the negative edge trigger, sorry, level triggered. The same way edge, positive, whatever positive is there, positive edge, the sequential circuit which will turn on at positive edge, only at positive edge, that sequential circuit will called as a positive edge triggered. Okay, so the same way negative edge triggered. Clear? So triggering will be different. Level, positive level, negative levels are different. Levels means you are talking with respect to clock. Trigger means you are talking with respect to clock and sequential circuit. When sequential circuit will turn on, so that you are saying based on the clock. Clear? So this is the thing with respect to clock and clock related parameters. If you understand this, so then I will go with okay, the evaluation of a sequential circuit. How the sequential circuit step by step evaluation is happened, that I will teach if this one is completed. Clear, right? Now see, very important thing, focus. First what happened? They took one inverter. They given input 0, output will be 1. Input 1, output will be 0. This is the first they observed. The second case what they did, they took 2 inverters. They given the feedback like this. So then what is the output we will get here? Like this we will get output. Yes or no? So if it is 0, 1, then again 1 it will comes, again 0 it will becomes like this output. So now the second case what they will do, so they now inverted, they added one more inverter. Now this one is 0, this one is 1, this one again becomes 0, 0 will comes here. So now 0 is completely looping. See. So in a sequential circuit, combo circuit we already discussed. If we discuss about memory element, so if you know how the memory element will work, so then sequential circuit is completed. Simply if I want to say. So that memory element only we are discussing now. For storing any one bit, there are two things we need to be passed. To store one bit, we need to pass 2 things. What are 2 things? The memory which need to be stored 0 and which need to be stored 1. Getting? Previously it is stored 0. So if I give 1, it need to store 1. means it need to replace 0 with 1. If I will, if previously it is 1, if I will give 0, then it need to replace 1 with 0. These two cases will be possible. Then only I can say that is my memory element. That is my memory element. So now if you observe here, so if I will give 0, 0 loop will happen. If I will give 1 loop will happen. But I can't give any other input, right? Yes or no? I can't give any other input. Either 0 loop will happen, either 1 loop can be happen. But if I want, okay, if once I will give, after that I can't give any other input. It will rotate only that 1 or 0 loop. So now after this, what they did, third evolution is, so they introduce one OR gate. They introduce one OR gate. Now let's assume this input is 0. So here previous consideration 0, 1. So then 0, this 0 is coming to here. 0. Okay. So now 0, 0 is there. 0, 0, 0. 0 is looping. So if I give 1 here, 1, 0, any one of the input is high OR gate, output will be high. This is 1, this is 0, this is 1. Now 1 loop is there. Okay, means 0 I stored, so 0 to 1 I make. So now 1 is there. Okay, so now again I am giving 0. So 0 and 1, 1. Means I can't make again 2, 0. Means 1 already there, 0 to 1, 1 to 0. This will not happen in this third position. 1 to 0 will not happen. Now they went to fourth. In the fourth evolution, what they did means, inverter, one more OR gate they introduce. This one is 0. Previous consideration, this one is 0, this one is 1, 1, 0. This 0 is coming as feedback. Clear? So now if I will give 1 here, 0, 1, this one becomes 1, 0, 0, 1. This one is coming to here. Now again I am 0, I am giving 0 also, this will be 1 only. So now here one more input is there, right? So now reset this one I need to make 0. I need to give here also 0. So this is 1, right? This one is, sorry, this one is 1 inverter, this one becomes 0, 0, 0. Wait, we are missing the things. Yeah. Clear? This is 1, okay? Here also 1, this becomes 0, right? So this is, we given 0 also, it will not take now. Because it is 1, any one of the input is high, output is high. So if I will give here 1, 1, 0, it is 1. This one becomes 0. This one, output is 0. Yes or no? So now it is become 0, right? Yes or no? Means 1 to 0 also happened. 1 to 0 also happened. 0 to 1 also happened. 1 to 0 also happened. Both cases it will happen. If you want, you can see now 0 is there. If I will give 1, 0, 1, 0, 1, 1 means 0 to 1 happened, right? So if 1 here, 1 is there. So if I will give, okay, so this is 1 becomes 0. If I will give here 1, 1, 0 means 1, 0 means 1, then it becomes 0, right? This 0 only, right? Output. This 0 is coming as feedback, right? Yes or no? 0 is happened, right? 1 to 0 to 1 also happened, 1 to 0, both cases are happened. Now, if you observe, one OR gate, one inverter is there. These both together, how I can write? One NOR gate I can write, right? Yes or no? So now see, this is one NOR gate. Clear? And this is one more NOR gate. This is feedback, it's coming like this. Okay, this one. So now whatever I'm giving here input, this will becomes here output Q. Okay, this one is, this position is Q bar. Clear? This is a NOR gate 1, NOR gate 2. The same thing, if I will represent here like this is Q bar, this is Q, this is one input, this is one input. So one more NOR gate 1, one more input is connected to Q. Okay, NOR gate 1, this one, NOR gate 2, this one more input is connected to Q. NOR gate 2, one more input is connected to Q bar. Yes or no? Q bar. So this one is, this is only SR latch. Getting? So in the BTech, you seen this structure, but what is the behind the story? You don't know. This is the behind the story. These are the steps they make. So then they make the one SR latch, which is a memory element. First memory element. Clear? First memory element. This is the SR latch. Clear? So now go to the truth table. We'll see the truth table of this SR latch. SR. So I already told. So it will have 3 inputs. Already told. So if you observe, this is a Q. Memory is going back. Getting, this is also one input. Getting, so SR QM Q bar. This is the thing. So now 0 0 memory 0 1 case will be there. Memory 2 possibility will be there. Memory either 0 either 1. 0 1 memory 0 1 case will be there. 1 0 0 1 case. 1 1 0 1 case. Now S equal to 0 or also 0. S equal to 0 or also 0. So now my memory is 0. My memory also I am considering 0, first case 0. So now this both are 0. Any one of the input is high, output will be low. Both inputs are 0. So then what is the output? High, 1. This 1 is coming to here, 1 0, 1 0, output will be 0. Getting, output will be 0. Means if the memory is 0, output will be 0. If this one is 0, Q bar should be 1. Q bar will become 1, right? So one more thing, the state will be valid and invalid. How you will say means Q is not equal to Q bar. This case should come. When it will complete, this state should come. So this condition it satisfy, then I can say that is a valid. Otherwise it is invalid. So now S equal to 0, R equal to 0. My QM is, memory is 1. This is 1. So then 1, any one of the input is high, output is low. This one is 0. 0 will comes here. 0 0. This one becomes 1. Means, okay, what is the output? It becomes Q is 1, output is 1. Output is 1, this one is 0. Okay, means whatever the QM, the same thing Q it is passes. This is called the memory state. Memory state or holding state or latching state. Getting? Holding state, latching state, memory state, many names. They will call with many names. Clear? So this is S equal to 0, R equal to 0. Now, second case. S equal to 0, R equal to 1. R equal to 1. Okay, S equal to 0, R equal to 1. In this case, if you observe, so I already told what is the NOR gate single statement. Any one of the input is high, output will be low. No need to check for other input, right? I can directly say output will be 0. Means Q will be 0. This 0, if you go to here, 0 0, Q bar becomes 1. If suppose previous q, if you consider 0 also, okay, so 0 0, q bar becomes 1. Okay, this 1 being 1, if it comes 1 1, output is 0. Getting? Output is 0. If q is equal to 1, if you consider also 1, if it is 0 1, 0 1, this is 0. This 0 is coming here, but this is 1. 0 1, output is 0. So means anything if you consider 0 1, memory is 0, if you consider 1, it is considered output is 0. Both the cases, this one also 0, this one also 0. Getting? So this case will call the reset. Reset. Value making 0. That bit is reset. That bit becoming 0. Memory element becoming 0. Simply. Clear? So now next case. Okay, 1 0. That's what only I'm saying. I will repeat. See, q is 1 memory. Okay, s is 0, r equal to 1. This 1 memory is going to here. 0 and 1. What is the output we will get? 0. This 0 I am getting here. 0 and 1. What is the output we will get? 0 we will get, right? Yes or no? 0 we are getting. So this 0, if you go to here, 0 0 0 0, this become 1. Getting? 0 0, it will becomes 1. Just for making, see, it will not check the memory. When r equal to 1, it will not check the memory. Directly you can know that, okay, any one of the input is high, output will be low. Directly q becomes low, 0. Even memory is 1 or memory is 0, it becomes 0. Clear? So that is the thing happened. So now next, so this one is 0, this one is 1. Okay, this one is 1. I already told any one of the input is high, output will be low. Output will be low. So this one is 1. So then what is this one is 0. This 0 will comes here 0. This one is already 0 0 0. This one becomes 1. This one is coming here 1 1 0 only. So no, means 1 1 0. This q becoming 1, right? Means either memory is 0 or a memory is 1. If s equal to 1, if s equal to 1, output will be 1. This is called the set case. Set case means you are setting the value to the memory element. You are resetting the value to the memory element, it will become 0. So if you are setting, so then it will be 1. So now next case is 1 1. S equal to 1, R equal to 1. Any one of the input of an OR gate will be high, output will be low. This one also low, this one also low. Q and Q bar both are low, both are 0 0. Invalid case. Either memory is 0 or memory is 1. It is a invalid case. Getting? That is invalid case. This is the